first thing that we're going to do is we're going to try to cut this angle on the front at 5 degrees. And you can see I have my fixture. It's already been hogged out for that. My pin, my pivot point's an 1/8 inch in. I got a 1/4 inch in mill. So what I need to do is I come up to about 375 on my digital from my 0, and then that will give me just about perfect what I need. After we get the pocket and everything in, we'll put an insert and we'll sand. The relief is going 5 degrees the wrong way. It's tilted back that way. We got to have the relief on the bottom that way. What we're doing, we're trying to establish the relief this way, but we're taking a lot of the material away. So it will get sanded when we put an insert in there, so it'll come out perfect. The next thing that we want to do is we want to establish the center line, and we want to use the same 1/2 inch in mill, and we want to cut the angle going across this way. We'll loosen the screw up. Normally I wouldn't fiddle around with this much, but I'm trying to stay out of the way of the camera. What I want to do is get a rough center height on that. And again, because we're going at an angle, I want the center height on the very end of the cut. That's one reason why I cut some of this away. And so here it's just going to be eyeballing. I'm going to get on the other side a minute here. And that looks just about right. You got a 1/2 inch bar, so I want to go 250 thousandths down. I'll go up 50 thousandths at a pass. And let's see, I need 245. Okay, so we got that part done. What we're going to do now is switch to an 1/8 inch end mill, and we're going to actually start putting the pocket in. I'm just going to take some of that burr off real quick.
Still going, I'll be right back.
Okay. What we're doing now is we're going to move back to the 5-degree setting. I'm going to ink this part up, and I'm going to come down and just touch the end mill and establish my 0 for that. And I want to go 95 thousandths deep from that point. I set up at 5 degrees because I want to cut down the center past where the screw will be back, and where you got the V where the insert, I want to add that little clearance back there for the tip. That will help you when you're doing the sides, not having to guess where you're at. We're at the proper depth right now. So now I'll change the angle. We'll get that idea. What we're going to do now is we're going to cut one of the sides of the pocket. And now that I got my depth established, I'm not going to change it until the pocket is finished. Here you got to be careful because you don't want to run into the posing side. So you got to take it easy. What I did, I miscalculated on the distance that I moved on the one bar. So I quickly made another one with a pocket to get where I was at. and I rewrote my numbers so that I can actually have the numbers with the digital. What I did, I forgot to factor in half the diameter of the end mill, and I went too deep on that. But with this bar, I'll just go ahead and cut that off, and then I'll have a single end. This end is good. So right now I just finished getting the one side on here. And one thing that I didn't mention that you're going to want to do, because you got the different holes and stuff in here, when you adjust this, you'll get chips and stuff that'll fall in there. So just go ahead and pull it all the way off. Wipe it down, because you want those surfaces to be nice and flat. So now we'll come over, and you can feel with this, if there's anything under it, it'll rock. So if it's feeling nice and flat, then there's nothing under it. Now we'll get this other pocket. The other side of the pocket, I should say. Now we have the pocket with straight walls set up. Now one thing I want to show is with the straight end mill, I went in a little bit further to the side, a couple thousandths more than what I needed to, because when I put the tapered end mill in there, I'm going to come down and I'm going to go a certain distance. Now a lot of times these inserts on the bottom side, they're really sharp on this edge on the bottom side. I have it turned upside down, so on this edge right here, it's really sharp. So if I try to make that pocket exact without trying to give some relief down in that bottom corner, what sometimes will happen is, even though I'm using a square end mill, it could hang up on that a little bit. By giving that a little bit of relief in the very bottom there, that will prevent that from happening. And to show what I'm talking about, I'm going to put some Dykem in here. And so when I mill the taper on there, you'll be able to see what I'm talking about. The end mill I have is just a high-speed steel. It's a 11-degree taper. What I'll do in the future here, because I found with MSC it was kind of hard to find, at least when I looked, it was hard to find that tapered end mill with a 7-degree. You can find it in 11. But I see that Harvey Tool online, I saw that they had some carbide ones that I'll have to look into, and they had quite a few ranges with different degrees on that end mill. What I'm going to do is I'm going to try to find right at the very bottom and then just lift up maybe about a half thou, because I got the bottom all shaped with the straight end mill. And when I find that, I want to go to that side of the insert because if I touch the bottom, it's not going to hurt on that side. But if I'm on this side, and then it takes away, could take away, if you touch heavy, a little bit of strength right under the cutting edge. I go back and forth 3 or 4 times just because I want there to be no flex in there, and I want that wall to be cut with that 11 degrees as accurate as I can. So I have the one wall cut. We're not going to change our zero heights. Okay, Adam, let's see if you can get a close-up in here where we can show where the red's at, where the straight wall is. Show how we've done the relief there. We're almost done. What we're going to do now is we're going to put the hole in. And one of the things I have this design is when I got the hole, I got the walls on the sides cut so that when I put the hole in at 0 on my digital, it's actually about 6 thousandths interference with this insert. In other words, if I put the insert in the pocket, the hole's about 6 thousandths lower. And what that does is when you screw that in there with that shaped head, because it's lower, it actually pulls the insert. It pulls the insert and a lot of pressure up against the side walls. And then that way, you don't have to worry about the insert twisting and turning. If I would try to drill that and get that right on 0, and I happen to be off so that the hole's actually a few thousandths the other way, well, that's going to lock the insert where it's not going to be touching the side walls. By offsetting that hole like that, you're always going to get 100% contact on both sides of the insert with the boring bar, and it'll hold in there real nice and tight. You started to tap in the mill to get it going straight, but I can't tap it all the way through because we have that dowel pin in the way, so I'll have to finish it up by hand. In the future, if I ever make another one of these, if I make the plate thicker, I'll have plenty of room where I can just tap all the way through. Another thing I could do is use maybe a 3/8 pivot pin and then put a 3/16 hole all the way through it. That'll give clearance for the drill and the tap. So now we have, all we have to do is do a little sanding and a little cleaning up on the edges. So in order to do that, the first thing I'll do is I'll take this insert out. Pop it in on that side. And I don't know if you can see that on the camera or not, but because this was milled on this relief on that edge, the material sticking out on the bottom here. It's sticking out on the bottom. You'd hit your shoulder there. I got to hold this up at an angle, and then I got to grind it so that I got that same relief angle as the insert. So I'll pop a used insert in like that, and then I'll go over here to the sander. And that works pretty nice. If you got the carbide in there, it keeps you from grinding in too deep. But what you do is you can grind until it's nice and flush all the way across there. So once you have that done, I'll be using the Scotch-Brite wheel over here to remove the burrs. You got a nice heavy burr around here, you got sharp edges here, nice burrs around here, and the Scotch-Brite will work real good. The thing that you got to be careful about, you want to be careful that you don't get too aggressive in the pocket and mess it up. Now you can see it. Adam can get a close up on there. It's all deburred, all shaped real nice. And now you got a double-sided boring bar. And that's the little fixture right here. Can't do it as fast as CNC, but you can do some amazing stuff. And again, by doing the calculations with CAD, if it's handy, you can do whatever shape insert you know, that your imagination can come up with, and you can do some pretty nice stuff. And a lot of times I find the stuff I built, I like a lot better than the stuff that I can buy, because I can customize it to exactly the way I want it. And on these particular bars, I'll have to make 3 more of these, because there's some people that are already wanting some of these, and so I'm going to make, I told them I'm going to do a video, and so I have some co-workers that are wanting some, and so I told them I'd give them the guinea pig special on them. They can just pay for the materials, and I'll make them the bar, and hopefully they'll like them. And the nice thing is they're soft. They can take and go ahead and stamp their name right in the side. Then they have them heat treated. Now they got a personalized boring bar. So anyway, that's it for this week's video. We hope you enjoyed it, and we'll see you next time.